Frankly speaking, I don't see any laptops. Only one. Okay. Anyway, then plan is the next. I'm going to demonstrate what is Fluxnova platform, specifically what components we have, how such components looks like, and what specifically we can do. Then I'm going to go through BPMN elements that can help us create BPMN processes here. You can see that Fluxnova is an open source BPMN platform, and everything that I'm talking about located in GitHub. You can use these specific links to get source code, run it, play with it, and but let me go through. We have Fluxnova BPMN platform. It's literally everything that we can run. It consists of different components like monitoring component, task list, administrator, and engine itself. Also, it has pretty UI, and I can show you later. Next thing is Fluxnova Modeler. This is editor tool that can help us build BPMN processes. Fluxnova Field Scala. What else? Yeah, this is script engine that is being used for DMN. I also cover this topic later. Everything else probably not very interesting for you, but you can pay attention to Fluxnova docs manual as well as Fluxnova examples. For our session, I will use IntelliJ IDEA, and specifically, I already downloaded example from GitHub. Now I'm going to run it and show how it looks like. From source code point of view, this is just a regular Java application. You build this Java application using, I would say, any kind of development approaches. You can use trunk development, you can use, I don't know, Git flow development approach. It's up to you. There's no any restrictions here. But what is important? We can have here some code specific to BPMN. And this code, I also describe this code later a little bit. This code will be executed or will be orchestrated by engine, Fluxnova engine. And let's see how it looks like. Oh, yeah. I'm navigating to localhost. And right now, you can see example that I ran. You can see here 3 out-of-the-box applications: monitoring, task list, and admin. What does it mean? It means that you have a platform where you can do very specific tasks. For example, if your business process contains user tasks, you can manage such user tasks here in task list. This is very empty example here, but let's make it more interactive. I just created, okay, let me step back a little bit. Right now you see a Fluxnova Modeler. This is editor tool that help us design diagrams or workflows. I created very simple workflow. I have activity that does nothing. I also added here user task, called it user task. And now I want to deploy such process into a Fluxnova engine. I can do this quite easily. Let me deploy it. And now let's see what we have here. If I switch back to our welcome application and to navigate to monitoring, you can see that we have one process definition. But what does it mean? It means that process that I developed and deployed can be run. And let me do this. I navigate to task list, use start process ability, select this process, just start it. You can see that a process has been started. Now let's validate what happened. I refresh the screen and you can see that we have user tasks. All tasks, one user task represented here, and such specific user task is not claimed yet. If I switch back to monitoring, you can see that we have one running process instance. I click on it, click on this process definition, and here you can see this process instance. And let me describe relationship between process instance and all similar stuff. Process is just a process definition. It defines a way how your logic should work. But process instance is very specific run of such process definition. We can run the one single process definition multiple times. In such way, we still have one process definition, but we can have a multiple running process instances. Here, every process instance has its own ID, start time. If I click on it, I drill down into this specific process instance. And every process has concept of execution token. This is exact such thing that you see here. This token shows what specific activity is being executed right now. We have ability in BPMN split such tokens. It means that we can do one or another work concurrently. We can join our tokens. It means that we can synchronize our concurrent threads into one thread and then continue to do something. There is concept here also variables. It means that when we start our process, and let me do this, you can see that we can provide variables. Variables just something that we want to pass into specific process instance and use it during process execution. For example, string data. We can provide data type. This is just simple things. We can specify value. Let me start it. You can see that we have two user tasks here. It means that we have two concurrently running process instances. And if I claim this task here and load variables, you can see that user has access to variables that I pass in during process start. Here, I as a user can do something with such data. For example, I can modify string data. I can add my own variable. and finish task. If you switch back to monitoring, you can see that we have only one running process instances. Process instance that I used before has been terminated because user task was the last task in the process. What ability we have here? First, we have ability to see how many. Actually, this is just operational panel. Here we can see how many running process instances we have, how many incidents we have. Incident is something bad that happened to process execution. For example, we try to talk to external system, for example, or we try to process data that was not validated correctly, for example. And such way we can create incident. Incident is a really bad thing in BPMN world because in this case, BPMN process execution stopped, and this is hard stop, and it means that user should decide how to fix this, and this is a really bad thing that may happen. Also, we can see open human tasks, literally all user tasks that should be addressed by one or another person or person group here. Another thing connected with task list. Task list is a central place for user task management. We can configure our Fluxnova platform such way that we divide our users into groups. We can give a specific permission to specific groups. And such way, we also can assign specific user tasks on our diagram for specific groups or a list of groups. And this way, Fluxnova engine cares about delivering right tasks to right person. Here, I don't want to spend much time here describing such thing, but do you have any questions? Yeah, this is a great question. Right now, there is no difference. Fluxnova was forked by Camunda 7 Community Edition, and right now this is completely the same. But I don't know if you saw or not, but we represented roadmap. Oh, I see. I see. I see. I see. I see. No. Right now, Fluxnova is 100% compatible with the latest Camunda 7 Community Edition. This is good because in this case, we can migrate smoothly.
Work is there under migrate to like if you got Windows stack Fluxnova, how much work is there?
Okay, let me say this. There is migrator tools that we can use. And it literally just a matter of replacing one package's source code with another package names. Here, the whole migration can be done very easily at this moment. But it might be nuances because not all companies uses the latest Camunda version. Probably someone uses older version. In this case, they also can try use migration tool, but there is no guarantee because it might be gap between versions here. It's better to migrate to latest Camunda community edition first, and then use this migrator to Fluxnova.
It's better to do it because what there are the qualities.
Yes, I believe so. I believe so. Okay, I also want to say a couple of words about admin part. Here we can specify our users, our groups, and manage authorization. For example, in authorization, on authorization page, we have resources we want to talk with, to work with. For example, we have task resource. It literally means every user task in system. But we can configure this thing. We can specify or allow or deny, it depends on your needs, specific permissions to group or user. Here, for example, the same thing for process definition and process instances. By default, Fluxnova admin group has full access to everything. But if you want to use your users in system, we definitely need to configure this part as well. Any questions?
You start to go for
Oh, yeah, great question. Great question. Let me show you. I demonstrated source code links here, but I forgot to say that we have a site FluxnovaFINOS.org where we have everything connected with Fluxnova. In such way, you can see that we have documentation. It looks something like this. You can read it, you can use it for your needs here. And right now, this documentation compatible with Camunda 7 Community Edition. But in the future, it also will be updated, and yeah, it okay, and will be completely different because we have roadmap, and I believe that we bring new features to platform here. Okay, I would like switch to modular and go through specific BPMN elements, if you don't mind. I want to go through building elements that we can use for build BPMN workflows. All elements that can be used in BPMN can be divided into three big categories. First category is events. Events are divided into three kind of events: start events, intermediate events, and end events. It means that if we want to start our process, we should use one of such elements. We can start our process via API, or we can start our process via sending message, or via sending signal, or even we can write our process such way that it can be run periodically using a time start event here. Also, we have end events. Every process that we start, I believe, should terminate it one or another way. And here, examples or available features that can be used here. If no action should be taken at the process finish, we use such thing. But if we want to combine our process termination with something else, it's better for us use combined symbols here. If you want, for example, to terminate process and send message or send signal, we should use such elements. If you want to notify Camunda, Fluxnova engine about errors that happen in our process, probably the better way use error and event here. If you want to collaborate with parent process, such way we are going to use escalation and events. And if you want to terminate all concurrently running tokens of the process, we should use terminate and event here. Also, we can use our intermediate events as a part of a flow diagram, such way. If you want to receive something, for example, message, signal, information about time, or tie a really big process, or split a really big process into parts, or send escalation, send escalation or notify parent process, we should use such kind of. If you want to read or send, if you want to send messages, you should use such elements. Here, we can also need to describe how we can combine our signals or our events with specific activities. Activity, let me show you this. Every activity on diagram represented actual work that can happen. This work can be done by system or by human. In such way, we can split all our activities into activity types. For example, we might have user task, we might have service task or script task. The difference here is the next. Service task is something that implemented in source code, like Java code or Kotlin or whatever. But script task is something that implemented in JavaScript, for example, or Python. And difference here is the next. We can provide such script as a part of our process and define logic using BPMN. But for service task, we need to modify source code. There is another activity, which is business rule task. This activity literally have a reference to a business rule table or DMN and provide inputs and outputs for such DMN to be executed. Also, we have a call activity that just call another process we define. In such way, we can have a chain of calls, different processes according to logic. We also have a send and receive task here. How can we manage our execution flow here? In this case, we are going to use gateways. Gateway represented by such 5 elements, and logic is the next. Exclusive gateway have a choice only of one flow that is possible. Inclusive gateway allows multiple flows possible. parallel gateway just split our execution flow into a predicted number of flows. Event-based gateway allows us wait a set of events we want to wait. For example, if we send a message to different process and now we want to wait response back, but we want to set timeout, right? In this case, we should use event-based gateway with two elements after it, which is receive message and timeout element. I demonstrated a little bit later. And also we have a complex gateway. Sorry. Also, I would add next, if we have multiple incoming connections to our gateway, it means that we join our execution. If we see multiple outgoing connection from our gateway, it means that we create additional execution tokens here. And what is difference here? If I'm talking about this specific exclusive gateway, it means that only one connection will be activated. And our process goes this way or this way only. But if I choose inclusive gateway here, in this case, we can activate 1, 2, or 3 flows at the same time. And if, for example, in first use case, we define conditions, right? When you reach this point of execution, BPMN should decide what specific flow should be chosen. And we use conditions here. Conditions represented by dual expression or by script. But the fact is the next. If we use exclusive gateway and if two conditions will be true, we will get incident in BPMN execution. It means that Camunda does not expect two true conditions here. And this is a really bad thing. And human intervention required here. But in inclusive gateway, this is absolutely valid thing. We probably want to activate first and second connection just after such gateway, and we will be good here. Parallel gateway duplicates our executions automatically. It means that there's no any conditions here. Only one thing happens. Once execution token comes to this point of execution, it automatically being forked into 3 executions token here. Event-based gateway can be represented something like this. In this specific situation, we are going to wait one of 3 events. First event is a message, second event is a signal, and the third event is a timeout. And specifically, it doesn't matter what happening here. Execution will be continued only for such connection. For example, if we receive message, it means that execution flow goes top flow. And even if a timeout or signal comes after this, we will ignore this. We already selected right path here. Okay, let's see, how can we group our activities with events. Events is something that can happen independently to process execution. And sometimes we want to care about this. For example, if we start our processing an activity, and if we know that during such processing can be a signal or message or any other event represented here, for example, escalation event happen, then, and we want to process such kind of events, we should use boundary event. This boundary event is connected with specific activity. It behaves like a handler for a specific event during such activity execution. In BPMN world, it means for us next. If we want to care about such kind of events during activity execution, probably we have two options here, right? And we should decide what should we do. Option number one, we want to, once we receive this event, we want to terminate our activity. If we have, for example, long-running processing happen here, and then we are waiting for specific message like cancel, right? We don't need to continue such processing because someone said, no, no sense, wait for us. In this case, we use boundary interrupting event represented here. But it might be a case when we have activity running and we want to aware about specific events that happen during such activity, active time, but we don't want to terminate such activity. Example, if we have user task and this user task assigned to specific person, it means that this person should solve this task. But for some reason, he probably switched to another task. But we have restriction, or we have rule that every user task should be complete during, I don't know, 7 days. In this case, we can use a non-interrupting boundary events for sending notification to user. Hey, you have a user task you need to work on, and 3 days already passed. Please pay attention to this. Here, this way we keep our activity running, in this specific case user task running, but we execute such logic here. And this is not a problem, but there's nuance here. If we have a look on execution token flow, in this case, it will look like this. Our process executed one by one and stopped here. Then when interrupting boundary event happen, we go such way, top way. And finally, we terminate our process because this is end event. But if we have a look on bottom use case, it means that we have one token that sits on activity, and then Fluxnova will create second token, execution token. And this second execution token will flow from this element to this element and this element. And it means that in this case, we have concurrent execution. We have something happen here, and also we have something that happen here. And Fluxnova supports this as well. Another thing connected with non-interrupting or interrupting escalation events. If we want to use call activities, specifically if we define our logic in a way when we split our logic into levels and we go from one level to another level, we make a calls. And it might be a case when something that happen on lower level wants to notify parent level. It might be any reasons, but I can give an example. If we think about this callable such way, inside this callable, we initialize, let's say, we have a robot, and this robot can move something from one location to another location. And here we just give a command to such robot. Take something from location A and move it to location B. This movement takes time, but we initiate such thing, and now we are waiting till something will be at location B. But we are going to show really great progress, for example, in such way. Once robot takes something, it can send message. I take it. In this case, we can use escalation, non-interrupting boundary events to deal with this. We can have still running command to a robot here, but we can update our command status. And such way, when the robot starts to move, it also can send another command. I'm moving, I'm at location A1, or I'm at location A2. And all such thing can be monitored by parent process using non-interrupting escalation events. And once robot reach a destination point, this callable terminated and whole execution context go to the parent. This is very useful thing that everyone love to use here. Okay, and now how can we combine our flows? Let's assume we have something that can be reusable. And in this case, we have two use cases. Use case number one, we want to share everything with such process. In this case, we need to use sub-processes. This is just a grouping of logic we want to use or reuse a specific level. There are different kind of sub-processes in BPMN. We have just a sub-process that represented here, but we also can have human sub-process. And this is also very useful element that is being used very frequently. And it means next, we can specify our event sub-process and say, if a message occurs or signal occurs or timer or whatever occurs, please do one or another thing. And it behaves like a global handler for such kind of message, signal, or timeout, or whatever. And such way, we don't need to put boundary events on every activity on diagram, for example. What else is useful here? Frankly speaking, I try to avoid use transaction sub-processes here, but we also have ad hoc sub-process. This sub-process also useful, and it behaves a little bit different than regular sub-process. We can define inside this sub-process activities we want to execute, but we don't specify a sequence of execution. It doesn't matter for us in which specific sequence all such activity can be executed here. If we are talking about BPMN, I need to talk about participant. When we build our, actually, there are two approaches here. Even like in development process, we can build our process from bottom to top or from top to bottom. I prefer to design processes from top to bottom. And in this case, we want to define participants. And BPMN allows us to do this. We can say, okay, we have a BPMN process that describes collaboration between 2, 3, 4 participants. And participant can be another component, or it can be external system. It can be even a person here. And such way, we can create participants in BPMN represented here. This is participant with 2 lanes inside. And here I show that even if we have one participant that describes what happened on its side, we still can have specific performers. For example, it might be system tasks. It might be, I don't know, support team task. It might be someone else tasks. And it's not necessary a human task if we are talking about teams here. Okay, when we define our participant, we also can define a way how such participants talk to each other. You can see that I used such kind of connections. Here, message flow. Such message flow only for visual representation or for documentation or for understanding how such participants collaborate with each other. But from technical point of view, it does nothing. It literally just for a human who reads such diagram. Here. Okay. Any questions?
So, I want to understand there are symbols like timers, timeouts, etc. So at the point in orchestration, then the tablet will just I need to finish this event in minutes, not throw an arrow. How does the diagram orchestration relate to the underlying computational length? Since let's we have a lot of processes, the instant processes is 1,000, and then you need a wall to finalize 15 minutes until they win.
Good question. Okay, let me say this. Fluxnova engine splits process instances or isolate process instances from each other. Means that you can't influence to siblings process running processes except of using signals or messages. If you know that you have process that does something, right? And you want to notify another process about progress or about something that happened. In this case, you send messages or events. But if you use timeouts in your process instance, it means that this timeouts applies only to this process instance. And there is variety here. In BPMN specification, we can have, actually, let me show you. we can have a very flexible thing. When we want to specify timer, we can use specific date when this timer fired. For example, you start process and you did your time calculation for process execution, right? And you say, okay, I want this process terminated exactly at this point of time. In this case, you pass in this date to your process instance and have a reference here. You specify here specific date and take this date from process instance variable. And you can calculate such a date for every process instance individually. Another case, you can provide duration, right? And this duration starts from point where execution token arrives to this activity. For example, if we are talking about user tasks here, it's not user task, but let me create it. If you are talking about user tasks and we want to create, let's say, timer boundary non-interrupting event here, we can do such thing. We can provide duration or cycle here. It's only difference how many times such event can be generated by engine. If you provide duration, it means that once execution token arrives to this activity, we start to count time. And when our duration is 1 minute, it means that after 1 minute, we just get such event and can do something here.
There's a follow-up question. What happens if I want to control multiple processes in a synchronous way? So I just define limit, timer limit, end of day when all these processes come. Can I define some orchestrate? So all these processes enter asynchronously, run it. You can make sure all are.
Yes, you can define it, but it should be a part of a process. And for doing this, you can use even subprocess. If you have any kind of processing, you can add even subprocess and define, let's say, even subprocess. And here you can define interrupting event here. And as a timer thing, you can specify date. In this case, it means that once you start your process instance, this timer starts to count time. And such way, you need to provide your specific criteria for every process instance here. You don't need provide boundary events on every activity. You can just use even subprocess and say, once this timer event happen, I want to terminate the whole process. It doesn't matter for me when, how many tokens we have, where execution is in this process or sub-process, or even in another callable. Doesn't matter. Engine does this for us.
I was asking because how to control the state of our computational layer with Fluxnova. It's possible or not. My last question is very simple. You mentioned scripts and services. For the scripts, what are the languages of the languages?
Good question. And there is a variety here. Specifically, Fluxnova supports all scripting engines that supports this 256, if I'm not mistaken. I might be wrong here, but There is Java API that allows Java engine execute any script engine. It doesn't matter if this JavaScript, Python, or Scala, whatever. And if this engine supports such GCR, Fluxnova supports this as well. Other questions? Okay, it looks like we are on a time.
If there are yes, not sure if they
As I know, there are a lot of training materials for Camunda 7, right? And at this point of time, such videos compatible with Fluxnova. But in the future, again, if we bring new functionality, it doesn't mean that we ruin everything, right? It just means that we bring something new. But BPMN, the beauty of BPMN is that this is specification. It literally defines how our business process looks like. And we can't break it, because if you break it, it means that we are not compatible with this specification, right? And it doesn't make sense to use it in this case.
Question. Is there a use case where you can initiate a payment from Fluxnova? Like, is that a box?
Okay.
Just a question. I know we are.
Okay, this is a really great question and deep question. Right now, I described only BPMN primitives that we can use in modular, but there is an ability to define our own functionality. It means that we can describe, for example, and we did this for our customers. We can provide a set of defined actions and put such actions here in the panel. Literally, it can look something like this. It can look something like this. We describe or we configure our activity such way that we say, I want to use such implementation. For example, Java code that can start order, for example. And we describe what inputs should be, what outputs can be. And when we describe everything, such thing becomes a template that we can use and apply this template for any activity on diagram. In such way, it simplifies user work or business analyst work on diagram creation.
Yes, is
Yeah.
maybe in the future like is they're equal somewhere, so that this payment initiate future used.
Yeah.
But yeah, I think we're out of time. Yeah. Okay. So thank you, Dmitry. Appreciate it.